Alright class, so this is the video explanation for this sapling question. And this is a great problem. I think it's very difficult. I think there's a lot of really great stuff going on in it. And really, you should all strive to completely understand this question. I just had some students finish doing this question in my office, and this is the whiteboard. So this is one problem, and we've got lots of different colors and some drawings. And this took a lot of work, right? And it took a lot of work, and the explanations for every single step, that's what's really important. So I'm going to try to work this out for you guys in a slightly more clear manner or organized manner, but you know, that whiteboard that we're looking at, that is what you guys need to be doing, writing out all of your work, annotating as you go, and I'll try to show you that here as well. So here's the question. I've rewritten it. Two 20-gram ice cubes at minus 13 degrees Celsius are placed into 285 grams of water at 25 degrees Celsius. Calculate the final temperature. So the first thing that I might do is draw a cup with 285 grams of water. That's at 25 degrees Celsius. And then we're going to put in our ice cubes, right? So it's a little confusing that it says two 20-gram ice cubes. We can just put in one 40-gram ice cube, right? It's going to be the same thing, and that's at minus 13 degrees Celsius. So we're going to mix these two things together. The ice cube will melt. The water will cool down. So our T final will be between 0 and 25 degrees Celsius. I think that is safe to say, a safe bet, right? If we put ice cubes into water, the temperature of the water will drop a little bit. Now, getting started with a question like this and drawing a diagram that sort of makes sense that we can follow, that's really the hardest part. And in my last video, I really tried to talk about that, and I'm going to do that again in this video. So I'm going to draw my diagram, and I'm going to start right here for my ice. So this is going to be my starting point for ice, and that's 40 grams, right, of ice. And the temperature of that is minus 13 degrees Celsius. And the ice, what does the ice have to do before it can melt? Well, what is the melting point of ice? The melting point of ice is 0 degrees. So the first thing I'm going to have to do is heat this up to 0 degrees Celsius. So that ice cube, when it hits that water, it's not just going to start melting immediately. It's going to warm up to 0 degrees, and then it's going to go from solid to liquid. So at this point, we're going to have 0 degree liquid, and then we're going to heat it up to some T final. So we'll say this right here is our T final, which is our unknown, right? So that's going to be the end point for my ice. Now, my water is going to start at 25 degrees. So the water is going to start at 25 degrees, and it's going to decrease in temperature to get to the same endpoint. So this is the endpoint for ice, and it's the endpoint for water, the same T final. So if I wanted to break this into steps, which is what we always like to do, step 1 is going to be heating the ice up from minus 13 degrees to 0 degrees. Step 2 is going to be that phase transition. This is going to be solid ice at 0 degrees. This is going to be liquid water at 0 degrees. Step 3 will be heating it up to the end point of the ice and the water. And then I'm going to say step 4 for this problem is going to be from the point of view of the water cooling down, losing some energy. Now, the real trick here is that the energy required for step 1 plus the energy required for step 2 plus the energy required for step 3, all of that energy that the ice is absorbing is coming from the water. From the point of view of the water, it's losing energy. So we're going to write equals minus the energy for step 4. And we'll talk a little bit more about the sign as I work through the problem, but this is going to be sort of the equation that will govern all the rest of the stuff that we do. But drawing this picture, right, drawing this picture properly and understanding, you know, how we're getting to this conclusion of this equation here, that's really the hardest part of this problem, I would say. So let's start filling this information in. So over here, I wrote down the heat capacity information. So for step 1, this is heating the ice cube from minus 13 degrees Celsius to 0 degrees Celsius. So this is a Q equals S times M times delta T. Now, in the problem, it gave you your heat capacities in terms of joules over moles times Kelvin. So we're going to need to convert, if we want to use these values, we're going to need to convert from grams into moles. Usually our S values are given in terms of joules over grams times Kelvin, the values that we're used to using. So you can use those values. That's totally fine if you just want to use grams, but since this problem is using moles, the heat capacity is in terms of moles, this would really be sort of a Q equals C delta T N equation, where C is our heat capacity in terms of joules over moles times Kelvin, so delta T, and then N for our number of moles. So either way you think about it, doesn't really matter. We just want to make sure that our units are staying consistent. So for our moles of ice, right, we got to make sure we have the right thing in mind. That's going to be 40 grams times 1 mole over 18 grams gives me 2.22 moles of ice. Okay, so for the energy for step 1, that's going to be C value 37.7, my delta T 13, and then 2.22 moles. So that is going to equal 1089 joules of energy. Okay, that's step 1. So this amount of energy, right, that is the amount of energy it's going to take the ice cube to go from minus 13 up to 0 degrees. At 0 degrees, it can start melting. So step 2, melting the ice. That's going to be Q equals delta H of fusion times moles, right? Because my delta H of fusion, that's how many kilojoules per mole it's going to take. So here's my enthalpy of fusion, 6.01 kilojoules per mole. So 6.01 times 2.22. That gives me 13.36 kilojoules of energy. So this is the amount of energy it's going to take to do that phase change. For that ice cube to turn into liquid water at 0 degrees, it's going to take 13.36 kilojoules of energy. Right away, I'm seeing that I've got a difference between my units here. Joules and kilojoules, we can fix that up when we need to. Let's move on to step 3 now. So step 3, the endpoint for ice, we don't know what that is going to be. That is going to be our T final, so we're not sure about that. But I do know if I want to calculate this amount of energy, right, that's going to be a Q equals S times M times delta T, which is really, of course, the same as saying C delta T N, depending on the units that I use for S or C. So in this case, my heat capacity that's given for water is 75.3. My delta T, I don't know what that is yet. T final minus 0, right? T final minus T initial, so that's simple. And then my moles, 2.22 moles. Just checking our units, moles here, 75.3. And then this is going to be an answer in terms of joules, right? This is a 75.3 joules over moles times Kelvin. So we can't do anything else with this. This is sort of our stopping point for step 3. We've got our unknown here, T final. Now, if you wanted to use this SM delta T and you use the 4.18 value that we're used to, then we'd have to use our mass, which would be 40 in this case. That works, should give you the exact same answer. You can definitely do it that way. Let's move to step 4. So step 4 is from the point of view of the water. So now we're going to switch to the point of view of the water. Very important. So from the point of view of the water is going to cool from 25 degrees Celsius to T final, right? So in order to calculate the energy associated with that, again, Q equals C delta T N or S times M times delta T. But in this case, with our C value that was given, that's going to be 75.3. Now this is going to be T final minus 25, right? So T final minus T initial, T final minus 25. And then I'm going to multiply that by the number of moles. And this is, again, we have to be very careful since it's the point of view of the water. I've got 285 grams of water which is 15.83 moles. Right, so I have to make sure that I'm paying attention to which point of view I'm looking at. So 15.83 moles. And again, this calculation here, this is going to be how much energy the water loses to the ice. Now, earlier we said step 1 plus step 2 plus step 3, that amount of energy is going to equal the minus amount of energy for step 4. The value of those energies should be the same, but the sign is going to end up being different because the ice cube is gaining energy, so positive value, this will end up being a positive value, T final is going to be positive, right? So these are all going to be positive. If I look at my calculation for step 4, T final minus 25, that's going to give me a negative value. So the value of this is going to be the same as the value of 1 plus 2 plus 3, but the sign is going to be different. So that's why up here I wrote minus the sign minus 4, basically. So let's move things around a little bit. So at this point in time, I could say for 1 plus 2 plus 3 equals minus 4, right? So step 1, I had 1089 joules. Step 2, I had 13,360 joules, so converting that 13.36 kilojoules into joules, plus step 3, which is going to be 75.3 times T final times 2.22. That's going to equal minus my step 4 values. 75.3 times T final minus 25 times 15.83. And this is my number of moles for my water. So this is from the point of view of the ice. This is from the point of view of the water. Now I'm going to solve for T final. This is a bunch of algebra. I'm not going to show it on this video, but basically, group these things together, multiply this out. You should get a value for this using my numbers of T final equals 11.3 degrees Celsius. So that is my final answer for this problem. So why don't we plug it into sapling and see what happens. Hooray, correct. Now remember, at this point in time, this is when your studying of this problem really begins. Just because you got the right answer, right? Just because you worked through this or you went to the tutoring center, you got the right answer, that does not mean you've done this problem how you need to do it. It does not mean you are a master of this problem. So at this point in time, now you want to go back through. You want to go back through all of your steps. You want to look over your work. You want to say, what does this value represent? What does this value represent? That's what we did on our whiteboard. We annotated, all of these things. What do these values represent? What does this equation tell us? You need to be able to do that for a problem like this, and that's really where studying begins, okay? So I'm going to leave you guys with that, and hopefully this helps.